We're doing a little bit of a recap because I forgot the video. Cent means 100, per means for every, so percent means for every 100. So we've got 10 people in our class, 6 of them are boys. So we're looking at what percent. So if I had, so we have a tape diagram, and if every one of these sections was 10, then we would have 100. So 6 times 10 is what?
60.
60. What's 10 times 10? 100.
100.
So for every 100, how many boys would there be?
60.
So what percentage of our class is boys?
60. Like I said.
60%. Now, I don't feel like doing this whole tape diagram to know what the percentages of girls. How can I figure out the percentage of girls quick and easy? What do you think, Nathan?
So if it's 10%, then like how many girls there are, which is 4.
Let's do it even quicker and easier than that. What do you think?
All you gotta do is 100 minus 60.
Why 100 minus 60?
Because there are 100 kids in our class if you have 10 multiplied by 10.
100% equals the whole thing, right?
So and there are 60%. 60% is boys, so you just divide by.
We just subtract.
Subtract 60.
By 40%. Yes, Ashley. Is that, but did you pretty much say what you were going to say? Don't you hate that? You're like, all right, so 100% equals the whole. So I can just subtract what part I'm not, you know, I want to find out the other. I could have gone back and said, like Nathan was saying, 4 out of 10 is girls. Multiply that by 10 equals 40%. Or I could just subtract the boys from the 100, okay? Is it ever possible to have more than 100% of something?
No. Yes.
Yes.
Maybe. No.
Well, I mean, if I say I have a pie, if 1 pie equals 100%, and I have 1.5 pies,
150.
then that would be 150%. But usually you're going to stop at 100%. Yes, Ashley.
Couldn't you adjust that 4 times 10?
What was that?
Couldn't you just have that 4 times 10 because that's 4?
4 times 10 because each of these sections was worth 10, right?
That's what I'm saying.
Yeah, so that's what you said. But I think subtracting is easier. Especially right now it's really easy because there are 10 people in our class. Are there always going to be beautiful things of 10?
Hopefully no.
No. In the real world, for example, let's look at the Barlow family.
Wait, can we do my family? Because including me, there are 13 kids.
Well, we're going to do the Barlows.
Okay.
I know in my head how many Barlows there are. There are 7 Barlows.
But I think I'm hard to divide.
Okay, and there are 5 guys and 2 gals. Okay, that's including parents. Okay, so I don't have 7 children, I have 5 children.
Including parents, 17.
Oh my gosh. So Zach has an enormous family. But you have a split family, so those get pretty big. So if I do this with a tape diagram, I'm going to divide it into how many slices? 7. 1, 2, 3, 4, 5.
6.
That was less than even, but we're going to pretend that it's even.
Yeah.
So how many of these are boys?
5. And then there's 2 gals.
Well, there's 2 girls, and we're not gonna do that in pink. We're gonna do the girls in purple because I don't like pink. Did you guys know that? I don't like the color pink. So we have boys and girls. There's the Barlow family. What percentage is boys and what percentage is girls? Well, first of all, what's the ratio of boys to total? Ashley.
5 to 7.
5 to 7. What's the value of that ratio? Ashley.
5 over 7.
5 over 7. Now, last time we were able to multiply by 10 super easily. What do we multiply 7 by to get to 100? This is where it starts to get challenging. What do you think, Ashley?
I'm gonna guess. 15.
She's gonna guess 15. Should we find out? 7 times what equals 100? Well, how can I figure that easily? I can go 100 divided by 7.
Yeah, that's what I'm doing right now.
100 divided by 7. Am I going to let you use a calculator on these? Yes, I actually am. Okay, I will let you use a calculator. Oh, Ashley, you were super close. It's 14.
Holy smokes, I was so close.
8, 5, 7, 1, 4, 2, 9. Okay, so here's the deal.
Yeah, I don't want to do the 2, 8, 5, 7, 1, 4, 2, 9.
I want you to not round in the middle of the problem, but I want you to round at the end of a problem. Okay? If you round in the middle of a problem, you can get problems.
Yeah.
Got me to show you how rounding in the middle of a problem gives you problems?
Yes.
I am going to show you. We're going to squirrel for a minute here with rounding. I'm going to show you that 1 plus 1 equals 3 for large values of 1.
Wait.
Wait.
Yeah, 1 plus 1 equals 2.
Okay, what? Okay, let me show you. What's 1 plus 4 plus 1 plus 4?
2.8.
2.8.
Oh, I said 2.
But what do those round to? What does 2.8 round to?
3.
What does 1.4 round to?
Back.
0. Yeah.
If I just saw these 1.4s and I rounded them at the beginning, I would have 1 plus 1 equals 2. But 1 plus 1, 1.4 plus 1 plus 4.4 does not equal 2. It equals 2.8. So don't round in the middle of your problem. We need it to equal 3. Okay?
Oh my gosh.
I don't like this.
We don't want 1 plus 1 to equal 3. I'm sorry. Just
When I was
exploded
in
your brain
third
a little bit.
grade, Blake came home and gave me a whiteboard that said 1 plus 1 equals 3 and asked me how it was possible.
I probably taught him that.
It was confusing.
When you were in 3rd grade, I think Blake was in 7th grade. I teach all my classes that. All right, so we're going to multiply 5 times that to equal our percentage. Okay, so that 100 divided by 7 times 5, it's 71.43, now I'm rounding, over 100. So what percentage of my family is boys? 43%. Okay, can I show you guys a nifty trick? If I just do 5 divided by 7, okay, 5.0000, what does that equal? Somebody pop that into their calculator for me. Let's do it by hand. How many times does 7 go into 50? 7. We have 49 minus, and then we have a 1 and a 0. How many times does 7 go into 10? 1. How many times does 7 go into 30?
4 times.
4.
Where's this guy?
How many times does 7 go into 20?
3.
Twice.
2.
Because 3 is 20.
Then 14, and then we have 60. How many times does 7 go into 60?
5.
Are you guys noticing something?
Holy smokes, I see it.
What?
Do you guys see the relationship
that.
between that
It's
and
7.
that?
Huh?
I'm going to actually change this. It's not 0.3, it's 0.28. Do you guys see the relationship?
You just moved the decimal. You moved the
If I
decimal.
times it by 100, I get the percent, 71.428%.
You moved the decimal.
So I can either do my ratio and figure out what each of these wedges has to equal, which is in this case it's 14.28, which is kind of a pain in the butt. Or I can say 5 divided by 7 is 71.428. Now what percentage of my family is girls?
4.
4.
2.
2. 8.
I don't know.
Percentage of my family.
Oh.
There are 2 girls. And the ratio is 2 to 7.
14.
And the value of that ratio is 2 over 7. It's not 14.
28%.
How did you get
I
28%?
just did 14 times 2.
It's not 14 times 2 though, because each one of these wedges is 14.28. It'd be 14.28 times 2,
I
Right.
totally
Which is 28.56.
which is why I'm letting you use a calculator, because sometimes these numbers get hairy. Or I could say 100% minus 71.428. And what does that equal? 28.57% of my family is women.
Mine's like 5'6".
It's rounding. I didn't round on here, you did round. So it's a rounding error. All right, so
Spell your name in calculator.
318830 is my name in calculator.
3188.
Uh-huh.
How can 8? 3.
318830 is my name. So,
On paper.
there's another way to do percents. Now we've been doing, guys, I'm talking over here. 4 is H, not A. You can't do an A on a calculator. We've been doing tape diagrams. I really, really like tape diagrams. There's another way to do percentages though, and that's with a 10 by 10 grid.
You really are gonna draw 100 tiny little squares?
I don't want to draw 100 tiny little squares, but I'm going to.
Holy.
Really?
10 years later. 1, 2.
Holy cow.
Oh my gosh.
Those are like perfect though.
They're not bad. They're not perfect, but they're not bad. There's my 100 grid.
Perfect in the bottom.
There's, yeah, I mean, it's this one got woo, but we do our best, right? Remember the deal. If I don't have to draw perfectly, you guys don't have to draw perfectly, okay? So it's good. It's good.
It's fair.
And on any of these where there's a 10 by 10 grid, I give you a 10 by 10 grid on your assignment, so you're fine. So let's say I have 5 fruits, okay? And I have, can you guys tell what those are?
Apple. Apple.
Those are apples.
Apple and banana.
Oh, what the heck? Oh, that's a pear.
Pear.
Oh.
So
For a second, I thought you were trying to draw
Yeah.
bananas and ivies. Like,
I have 3 apples and I have 2 pears, okay?
Same.
So I need to figure out what percentage of apples and what percentage of pears I have, okay? We're gonna do the apples in pink apples, and then green pears, okay? Because it's a little closer to, I have never ever seen a blue apple, nor have I ever seen a blue pear. All right, so we have pink apples and green pears. So guys, how would I model the percentage on this graph?
Put it on a red carpet and take pictures of it.
I would not put it on a red carpet and take pictures on
It's
it.
a model. What?
It's a model.
That's just one, but
Okay, so how many squares do I have?
100.
100.
Whoa.
But I only have 5 fruits. Yes, Nathan.
Double it.
Double it, so then I have 10 fruits and I have 10 lines, right? So how many of these lines are going to be apples?
what?
6 lines are going to be apples. 1, 2. Do you like how we color them in? 3, 4, 5, 6. Okay. How many of these lines are going to be pears?
Squiggle. 4.
4, because 2 times 4, because I need to get to 10, right? 1, 2, 3, 4. Now, how many of these squares are apples? How many, Austin?
60.
60 squares are apples. So what percent is apples?
60.
Now, what if, how did you know it was 60? How did you know it that fast?
Okay, so 5 times 20 equals 100, so I took 3 times 20 equals 60.
Okay, he did, 5 times 20 equals 100. You could also go 1, 2, 3, 4, 5, 6. 6 times 10 is 60. Okay, so there's lots of different ways to do this. What if I say that 11
Oh no.
of my fruits here have worms?
Uh-oh.
10 apples and 1 pear. What percentage of my fruit is wormy?
10% or 1%?
Why 10 and why 1, Hannah?
Because if you get 10, you can reduce it into 1.
But how many have worms?
11.
11. So where's the 10 coming from?
It's 11%.
11 out of 100.
Which would be
11 are wormy.
Wow, man.
If you blend
11% are wormy.
Do we get to eat the ones that are wormy?
Yes, can we?
I'm
You know, I'm not going to stop you from eating a wormy apple. It won't hurt you. It's just extra protein.
Really?
Yeah. I personally do not want to eat a wormy apple though.
An apple and take a
Feed it to your peacocks.
I would.
So, does anybody have any questions so far? I think we are good to go. I think you guys are ready to work on this stuff. Okay, I'll be walking around if you have any questions. All right, see ya.
Yeah, we get a calculator.